Hello, today we're going to talk about how to solve an absolute value equation. And one of the things I think is so important to understand is that there actually is a way to solve equations consistently through all of Algebra 2 and beyond. And you first were introduced to this probably in pre-algebra when you learned something called PEMDAS. It does leave out some things, but it's a good way to start. So in Algebra 2, we use something that I like to call GELMDAS. And what that is going to upgrade PEMDAS to, instead of saying parentheses, it includes grouping symbol. And instead of just having an E for exponent, it includes something called a logarithm, which we will learn many lessons from now about what a logarithm is. But a logarithm is actually the inverse operation of an exponent. Then we have multiplication and division, those are inverses, and then addition and subtraction, also inverses. And that is how you simplify each side of an equation before you start. But you can actually reverse the process and start at the bottom and go upwards by moving terms around with addition or subtraction as your first step. Your second step will always be to eliminate coefficients and eliminate negative signs using multiplication or division. The third step, which will come much later on, is to eliminate the exponent using its inverse. There's a variety of them. For instance, one way to get rid of an exponent is to factor. And if you've learned about factoring in a previous math class, what factoring does is it eliminates a square. We'll talk more about that in lessons to come. Right now, in this lesson, we're not going to be doing this step at all because absolute value is actually a grouping symbol. And you typically will take that grouping symbol and then resolve what is inside of the grouping symbol by going back down to the previous step. And if you follow this procedure, you will always know how to solve an equation. You'll never be confused about where you are or what you are doing. So let's look at specifically what occurs with absolute value equations. One last thing about this is please make sure, especially in Algebra 2, that you check all answers to see if they are what's known as extraneous. Extraneous means they solve algebraically, they work out when you do all these steps correctly. However, when you check them, you find out that they actually don't work in terms of the equation and what is given. And we'll see that in examples in just a few minutes. So looking specifically at absolute value is defined as the distance a number is from zero. So why that's so important is that if you look at this number line here, this distance here, okay, the distance that you're seeing on the left side of the here is 3 units. But that is the same as over here. This is also 3 units. So in the world of absolute value, -3 is the same distance as 3 from 0, making them equivalent. And that's the key to understanding this lesson. So to solve an absolute value equation, what you're going to do is you're going to isolate the absolute value symbol, the grouping symbol, using reverse GELMDAS. So we're going for this letter. We're going to set up 2 equations to represent the distance from 0. You're going to set the inside of that absolute value expression equal to a negative and positive value, and then reverse GELMDAS. And then you're going to check both solutions to make sure there are no extraneous solutions. Okay, in terms of inequalities, that's when you simply use a less than or a greater than symbol, or less than or equal or greater than or equal to symbol. You will solve the inequality the same way we just outlined above. But when you set up a number line to determine your answer, we're going to be using either an open circle, which is what we learned in Algebra 1. In Algebra 2, we actually learned that we can use parentheses, or a closed circle, which we learned in Algebra 1 for equal to signs. But in Algebra 2, we learned that we can also use a bracket to denote closed. Then what I like kids to do is I like students to draw a new number line that actually cleans up the graph. An example of what I'm talking about here is you may be solving an absolute value equation, and you may get a solid circle going to the right. And then you may get another closed-in circle going to the left. And students will frequently do this. Sometimes they'll even do this, right? But what you need to do is draw a second number line to denote that the actual answer is solidly between these 2 values. So you would just draw what looks like a barbell to denote that the answer is here. All right, let's take a look at some examples and see if we can review what we just learned verbally. All right, so here's our first example, our first problem to solve. And we're going to start by reversing PEMDAS, okay, on the left side. Ask yourself, is there anything I can simplify? And some kids from Algebra 1 might say, oh yeah, you can distribute that 5. You actually, it's a misnomer to think you can distribute, because believe it or not, distributing is only allowed with a regular parentheses. So I know up to this point, being an Algebra 1 or geometry student, you might say, go ahead and put that 5 in there. It's actually not allowed, because distributing is only permitted if you're distributing like quantities. And this 5 is not an absolute value quantity as this is. So we're going to work from the bottom of GELMDAS to reverse the operations we see. At the bottom of GELMDAS is addition and subtraction. So I look here. I don't look in the grouping symbol because that's the last thing I do, and I see this 4. So I'm going to add the 4 to both sides. That's your first step. And then once I do that, I'm going to simplify both sides. This one's easy. It cancels because it's the inverse. This one will make 10. And then over here, everything else will just drop down because we have not determined or evaluated any piece of that part of the equation. Okay, so once we have done that, what we're going to do is we have now completed the bottom step of reverse GELMDAS, addition and subtraction. So now we're going to do the next step, which is multiplication and division. And this thing that you want it to distribute, you actually undo it by dividing, because the inverse operation of multiplication is to divide. So once I have done that, I cancel this out because it's the inverse operation, and I evaluate this so that it equals 2. And this is the new thing, and one thing you'll learn about math is it's pretty much always the same procedures, but there's always one new step, and that new step is going to occur in Algebra 2 at either the EL level, the GELMDAS part, or at the grouping symbol, and in this case it's the grouping symbol. So what the absolute value means is this quantity is equal to this, but the absolute value is saying that this quantity is equal to its positive value, okay? So it equals 2, but it also simultaneously is mathematically equivalent to having another equation where the quantity is equal to -2. Because in the world of absolute value, you saw earlier on the number line I showed you, these two quantities are the same value. So what I'm going to do now is just reverse PEMDAS again. So I'm going to start back at the bottom, reverse GELMDAS. I'm going to reverse that by doing addition and subtraction first. Then I am going to drop down what doesn't change and evaluate this portion, and then continue to reverse GELMDAS. I'm now dividing, and so my first answer that I get is that x is equal to -1. The other answer that I'm going to have is to reverse GELMDAS over here, and you might ask yourself, well, that looks like exactly the same thing. And it is on the left side, but on the right side, I start getting different numbers. Here I have -6 now instead of -2. And then I drop down my 2x and I divide by 2. Again, it looks exactly the same on the left side with this inverse canceling, but here I get an answer of -3. So the new thing in Algebra 2 is also, like in Algebra 1, you may have been told by your teacher to review these answers just to make sure you get a good grade. But in Algebra 2, if you don't check the answer, you may think you're correct, but have an answer that actually doesn't work. So the way you check it is you simply take this number here and you plug it back in the problem and see if you in fact get 6. So you do that, and this is going to look like a pre-algebra problem when you see all this in here, is you're going to put this in a parentheses where the x is. So we're going to put that right there, and we're going to evaluate that using, in the old days we called it PEMDAS, but now we're going to call it GELMDAS. We're just going to go through the order of operations and see if those order of operations will yield 6, which is what it wants here. So let's see if it does. So this will make 2. -2, and then I add -2 to 4, okay, so the inside quantity is the absolute value of 2, and then the absolute value of 2 is 2, so I get 10, so 10 minus 4 is in fact 6, so this answer is valid. Let's see what happens when we put -3 in there. Okay, so this one also has to be valid to include it in my list of answers. Okay. So once I do that, we're going to complete this quantity. This is -6 plus 4, so that becomes -2. And now you can see how that problem is actually going to come out to the same exact value, because the absolute value of -2 is the same as the absolute value of 2. So this is, again, 10 minus 4, which is equal to 6. So we see that both of these answers check out. Now, what that means is I can write the answer as x equals -1 and x equals -3. So one way to write the answer is to simply say x equals -1 and then put a comma, x equals -3. But in Algebra 2, we learn about something called set notation, and we will talk more about this as we progress. But it's really a great thing to learn that this symbol in Algebra 2, it's a curly bracket, means list. And you may have seen it in previous subjects when you were younger. If you were looking at a set of data, they always had this symbol. And in fact, if you're a computer science kind of kid, you will notice that computer science is written inside of this curly bracket as well, because it is a list of instructions for the computer to follow. So when I put this in here, I'm going to put it in order, ascending order, so smallest to biggest. And this is also telling an Algebra 2 student that these answers are correct. In fact, if I really think about that, this should have probably been put in that order as well. So moving forward, if you're going to write it this way, you're going to want to also put it in ascending order, which is critically important when we do inequalities in just a few moments. So that's a better way to do that. All right, let's take a look at another problem. And notice I've changed it just slightly. I put a variable on both sides. It doesn't change the process. Okay, so you ask yourself, can anything be simplified here or here? The answer is no. So you start on the left side and you start reversing Gelmdas. The only thing I can do is get rid of the very bottom by adding that 4. And some students will say, okay, well, you now have produced, this just drops down. So some students will say, what's happened here is you have now produced a situation where it's almost like a loop. Like, what do I do over here? Because now you have 6x plus 3. Should I move the 3 over? Remember, the purpose is not to solve for x. The purpose is to solve the absolute value. So it's actually been solved. We are now actually done with isolating the purpose of the problem, which is to isolate the absolute value symbol, because that's the purpose of solving in Algebra 2, is to solve for the chapter you're in, the topic. So eventually we're going to get to quadratics and we will solve for squares. But now I'm solving for the absolute value, and now I obey what the absolute value says. The absolute value says that this quantity in here, 2x plus 1, is equal to 6x plus 3, but it's also equal to the negative version of that. So what that looks like is we just write down 2x plus 3, okay? 2x plus 1, and we set it equal to the negative quantity of this. So it's a whole negative sign, which would make it -6x minus 3. And of course, if that 3 were negative, which it's not, it would become a positive, because it's, think of negative as opposite. So the opposite of this expression is -6x minus 3. But the opposite of 6x plus minus 3 would be to put an addition sign there. Now I reverse Gelmdas again. Again, now I'm solving for x. So I like to put my variables on the left. It doesn't really matter, but it's very critical with inequalities. So what I'm going to do there is I'm going to solve that in this manner, where I am grouping my variables on the left side and my constants on the right side, and I'm going to be doing that using reverse Gelmdas. Okay, so I canceled this out. I evaluated this column. I'm now still at the addition subtraction stage. As you can see, you can actually use a step more than once to complete that out. This now cancels, leaving me with -4x. And over here, I end up with 2. And then I finally will complete this equation by dividing by -4. I'm now at the division multiplication step, and then I reduce my fraction. So my first answer is -1/2. Okay, over here I will complete the same process. I'll subtract 1, I'll do it on both sides. Here it cancels, but over on the other side, it gives me a new number that I did not have on the left side. So over here, I end up with -4, and then I'm going to add 6x. Notice that's a different step here because I'm now grouping my variables together. Forgot my little x there, I'm putting it in now. And then that will change because over here we had the original 6, but over here we have the opposite, -6. So the operation even changed, which is a neat thing to see. So here we end up with 8x is equal to -4. And then we divide by 8x, and we see an interesting situation where when this reduces, we get the same thing. We get -1/2. So the question is, why would that happen? Evidently, the distance that this equation produces is equivalent to the distance that this produces. And so the question now is, have we produced a situation that actually provides an answer? So let's check. Let's see if it did. So the absolute value of 2 times -1/2, okay, plus 1 minus 4 is going to yield, plus 1 minus 4, there we go, is going to produce, this will make -1 plus 1, so that's 0. So this comes out to the absolute value of 0, minus 4 gives us -4. So the question now is, does this give us -4? So when I see if this is equivalent to 6 times -1/2, okay, and then I subtract 1, right, I get -3 minus 1 or -4. So they are equivalent. -1/2 produces the same thing in the left as it does the right. And that's what you're looking for. That's really your overall goal, is to make sure that you've produced nice equivalent statements so that it shows the balance. Remember, algebra is really about finding balance within numbers, and this does show that this is the answer. So if you were to write that in set, you would just simply have a set, and it would just include one answer. Okay, so let's take a look at a problem that actually has some issues. This was an issue to have the same answer twice, but I'm talking about issues of whether or not something is correct solving-wise. So take a look at this example. I have a little stop sign here to try to get you to think about it. There is nothing to add or subtract outside of the grouping symbol, but when I divide by -4, what happens here is you end up getting the absolute value of x plus 3 is equal to -2. And I want you to stop and I want you to think about what that's saying. That is saying the distance from 0 of this quantity is equal to -2. And if you think about that logically, that has no solution, right? There's no solution to this problem. And we'll work through it and show you that if you didn't see it originally, that you would still get no solution. But it's really helpful to just know that, especially if you're taking an assessment, you don't actually have to solve that problem. Like logically, this doesn't make sense. Okay, so an absolute value quantity can never equal 0 since the distance is always measured with a positive number. Okay, so let's see what happens if we continued this problem. We would get x plus 3 is equal to -2, which is, the absolute value of x plus 3 equals -2, which is a mathematical fallacy. That's impossible. But algebraically speaking, algebra will work. So you could set it equal to -2, and then the opposite of that, which would be x plus 3 is equal to +2. Okay, and then you solve this by subtracting 3 on both sides. And when you subtract 3 on both sides, you get x is equal to -5. And then here you would subtract 3 and you would get -1. So a lot of my students will say, Mr. King, look, I got 2 answers. Did you check them, right? You got to check them. So if you take -5 and plug it into here, you would get -4, right? Absolute value of -5 plus 3. And -5 plus 3 is -2. So this would be -4 times the absolute value of -2, right? And that will come out to -8. Why does it come out to -8? Because this will become positive when I absolute value it. Well, let's see what it's supposed to equal. If it's supposed to equal 8. So the beauty here is the algebra is telling you you've produced balance. but you produce the wrong kind of 8. So you have the balance, but it's negative. So that answer doesn't work. This answer has to be excluded. It is extraneous. Same thing happens with -1. If I put in -4 and then the absolute value of -1 plus 3, I get a similar situation. I end up getting -4 times the absolute value of 2, which is again -8, and for the same reason, it does not work. So there is no solution even when you solve it. You would have saved yourself some time by going here and realizing that the distance couldn't be negative, but it proves it to you right here. So how would we write that as a set? Believe it or not, you can write it as what's known as the empty set, which is a set within nothing inside, or you could actually write out empty set. Believe it or not, that is also allowed to write out empty set. So there's also one more way to say this. We could say no solution, we could put a set with nothing inside, we could have empty set, or we could even draw this symbol right here, which means empty set. All right, let's take a look at some inequalities, following very similar procedures, but there is a little bit difference with the number line. So when you look at this problem, it looks almost just like the one we just did, but you see that this now says greater than or equal to. You cannot assume the answers are going to go that way. That is an Algebra 1 skill. Algebra 2, there's some more thinking involved. So I'm going to reverse PEMDAS by subtracting 4. It's going to feel very similar to the solving equation. Okay, and so we're just solving this very similarly to solving an absolute value equation. Nothing at this point has changed. This will simply drop down. So 8 minus 4 is 4. Then I'm going to divide by 4, and I'm going to end up with x plus 3 is greater than or equal to 1. This is the inverse, it cancels. This looks like it's the same, but you have to actually evaluate that. So obviously 4 divided by 4 is 1. And the same thing that happens with equations will happen. I'm going to have x plus 3, right? And I'm going to have the 1 because the distance from 0, remember absolute value means distance from 0, is the same at 1 as it is for -1. So when I look at -1, what ends up happening is this is so similar to solving, a lot of kids get lulled into a sense of, oh, it's the same thing. But what happens with this inequality is it actually reverses, and the reason it reverses is negative means opposite. So if I have the opposite of 1, what is the opposite of less than? It's greater than. So I have to apply this negative to the inequality. So then I have a pretty easy solving process. I'm just reversing PEMDAS again, giving me x is greater than or equal to -2. And then here I subtract 3, and I end up getting x is less than or equal to -4. And I'm going to want to draw that out on a number line. And there are two ways to do this now. So in Algebra 1, okay, you probably learned that it was important to use a closed circle for equal to problems. Okay, equal to means include, and mathematically speaking, if I put a solid dot here, that's saying include this number, and same thing with that one. And then you can simply look at the arrows. This is pointing that way, so at -2, I'm going to draw it that way. And then this one is pointing that way. But keep in mind that that only works if you have solved for the left side. If you have not solved the variable on the left side, then everything is backwards. So please don't be stubborn. Some of my students in the past have put their variables wherever they want. It's critical in Algebra 2 to put your variables on the left side. So this statement can actually be written in a different way. Instead of, we talked about previously that you can use set notation and such. Here, you would actually want to write out that x is greater than or equal to -2, and you actually want to put a special word here where you will say or, okay? Now, the reason that's important is when things go away from each other, mathematically, that is the concept of or. When they go together, that is called and. So in this problem, it looks pretty good as an algebra, okay? So again, or graphs go apart from each other. Now, mathematically, in Algebra 2, it's important to realize that this number line can also be written like this now. Instead of using a bracket, a solid dot, we can actually use a bracket to denote the same thing. So this answer, right, is the same as the one above. And you will see that in some textbooks, especially when you get to pre-calculus, that instead of using this open circle, closed circle, they use a bracket. And for an open circle, which we'll see in the next problem, they use a parentheses. Mathematically equivalent, these two things. Okay, so let's take a look at this problem. Again, now we have some variables on both sides, so I'm just going to reverse PEMDAS, solving for the absolute value side, maintaining the inequality as just a step that we're going to drop down. All right, so here we go. And then here, this will add up to now 8, or, 10. That'll add up to 10. And then we're done. There's nothing touching the absolute value, so the absolute value has been solved. We're now going to evaluate what it means in terms of the definition of absolute value. So the definition of absolute value says it's perfectly fine to have this distance maintained without a change, but that is mathematically equivalent to having this exact same quantity, but to have a negative on it, because the absolute value of a negative number is the same as a positive number. So, as I mentioned earlier, if you have a mix match like this, it will change both of them. It will become positive 2x and then negative 10 because it's opposite of the entire quantity. But now this will also change, and that's the thing that kids forget all the time. You got to change the inequality because the opposite of less than is greater. So now we're just going to solve this like a regular problem. Again, please don't be stubborn about how you solve. I know that in the past, especially with students who are really good at math, teachers don't really care which place you put the variable, but it is super important with inequalities to solve variables on the left side, or else the entire logic behind where the arrow goes on the number line is reversed. So I'm going to solve this 2x over here, okay, and that'll give me 6x, maintaining the inequality, okay. And then here, this will be 18 because these two things will cancel. And then I divide by 6 and I get 3. So x is less than 3. Keep in mind also, you might have heard in a previous algebra class, if this 6 were negative and you divide by a negative, you would in fact have to flip this, and you'd have to do it probably again over here. So keep in mind that all the rules you've learned in previous math classes, they must be maintained. All right, so over here, I'm going to add 8 because I'm reversing GELMDAS again. Did the addition step. And then here, I am going to maintain the greater than symbol because the opposite of less was greater, so I changed that when we wrote it down. And then here, instead of having this number, I now have negative 2. And then I'm going to subtract 2 on both sides to put my variables on the left side. I'm still at the bottom step of GELMDAS. Remember, I have to get rid of all my additions and subtractions. And then at this step, I'm going to divide, and this is sometimes confusing. I'm not dividing by a negative, I'm dividing into a negative. So it's always the operator that will change the inequality. This inequality will stay greater because of the fact that I'm dividing by a positive number, which doesn't change what has happened. Okay, so we end up getting x is greater than negative 1. All right, so let's take a look at that on a number line. These will be open circles because I do not have an equal sign. Remember, equal sign means put a solid circle because that means we include. Well, this is excluding, meaning this answer right here is everything below 3, but not actually 3. And then at negative 1, we'll also have an open circle, and that's going to the right. So keep in mind here, we're going left. Here, we're going right. And this is what I meant in my notes by please redraw your number line. That's a mess, right? So if I redraw my number line, what I will end up having is a nice clean version of the answer where I have a barbell-like structure between the two answers. So I have open here, and I have open here, which will include a barbell between the two, okay? And that's what the answer actually looks like. Please keep in mind that in more advanced classes, as I've mentioned, we can use a parentheses for this instead of an open circle. So we can also put a parentheses here at 3, and then a parentheses at -1. And some people will actually do it through the number line, so it's more precise, just like this, right? and then we would include the number in the line in between. So when you do an AND problem, because I have a little note here that AND graphs go in between points, as you can see here, it is sufficient to put this, remember, put it in numerical order, right? So actually that means I need to change this around. This should have been reversed. We should have written x is less than or equal to -4, or x is greater than or equal to -2. This answer is not wrong, but it's not perfect because we always do things in ascending order. So to do this in ascending order, we would write x is, you can just write right here, it's greater than -1, and, okay, and x is less than 3. But when you do and specifically, teachers like you to actually put it together like this. So one way to do it is to use inequality. So this would be the same thing as and. I know that that looks like one of them is reversed, but when you have two less than signs, mathematically that means in between. And another way to do it is to just use parentheses. So I can say -1, 3, and believe it or not, that means the same thing. These are equivalent, so you can use either, whichever one works better for you. Okay, so one last thing is, nothing went wrong here. These were just an example of or and. So what happens if something doesn't work? So let's take a look at this problem, last one. If I have this absolute value, and I say it's less than -4, think of logically what that means. That means the distance from 0 is less than -4. That means it's smaller than a negative. So if distance can't be 0, how can it be smaller than 0? So this problem also has no solution, okay? And if you solve this and plug it back in, it will also not work, just like we showed earlier. But the question now is, well, what would happen if this would have been a greater than symbol? The logic there would say the distance from 0 is greater than a negative. And if that happens, we have what's known as infinite solutions. Because again, if I had the absolute value of 3x plus 6 is instead greater than any negative, I'll put -4 because that's what the example is saying, this is always true. The distance, right? The distance is bigger than a negative. So how often will distance be measured out on a tape measure or on anything? You drive a car and you look at your odometer, how often will the distance be larger than a negative number? And the answer is always. So thinking about a number line, this number line would not have any answers on it. There'd be no answers. Where this one would have an infinite amount of solutions. So it's not something that's easy to draw or think about. So it's just better to say infinite solutions. Well, I hope that you enjoyed this video. I hope that you learned some things about solving that we can use throughout all of Algebra 2. The more time you spend with absolute value, the easier all of Algebra 2 becomes. So you may have heard of some things, some big words in Algebra 2 like factoring or logarithms, or all of those processes are actually fairly similar to this as long as we learn this process correctly. So in review, you're going to reverse, right? The big thing that we learned, it starts right here with reversing Gelmdas. Once you do that, you have to make sure that you do the correct operation at the grouping symbol or later at the exponent logarithm step. And you must check your answers to make sure that they are not false answers. All right, I hope you had a good video today, and thank you for watching.